Welcome to Math Proofs. My name is Adi Yoja, and today we're going to be proving why the derivative of e to the x is equal to e to the x. Now, some of you, particularly those who do not know what calculus is, may be saying, well, hold on, Adi, what the heck is a derivative? And I would like to offer this warning. This video is intended for calculus students. If you are not a calculus student, if you have not taken calculus yet, you may not understand everything in this video. I just want to give that out as a warning. We are going to be able to prove this by answering this equation. That is, what is the derivative of the natural log of e to the x? Now, how could we solve this? Well, for those of you who know your logarithmic rules, you may know that because x is raised as an exponent and e is being taken, it's being taken the log of, you can move this x down here. So the derivative gets simplified to be the derivative of x times the natural log of e. If you further know your log rules, you know that the natural log of e is merely 1. So we have the derivative of x. Now, what is the derivative of x? That is nothing but 1. And this is one way that we can solve this equation. But there's another way that we can solve it, and that is using the chain rule. So over here, we're going to use the chain rule of derivatives to solve this equation. Now, if you remember, the chain rule involves composite functions, things like finding the derivative of f of g of x. Let me color code things. Of f of g of x with respect to x. So let's see if we can determine an equation for this. We know that the chain rule states that this derivative is nothing but the derivative of f of g of x with respect to g of x. So the derivative of f of g of x with respect to g of x multiplied by the derivative of g of x with, with respect to x. And this equation can be solved given that you know what g of x and what f of x is. So let's try to take our equation. Our equation here was the natural log of e to the x, and let's try to find what f of x would be and what g of x would be. So my guess is that f of x would be the natural log of x, and therefore g of x would be e to the x. Now let's test this theory. Let's find what f of g of x will be. Well, we first have to plug in what g of x is. And we know that g of x is nothing but e to the x. So we have f of e to the x. Now, what do we get from this expression? Well, with the function f, if we plug in x, we get out the natural log of x. So if we plug in e to the x, we will get out the natural log of e to the x. So if we define f of x as ln of x and g of x as e to the x, when we find f of g of x, we get the natural log of e to the x, which was the equation that we had in the beginning. And now let's solve this derivative knowing all this. So this derivative gets simplified to be the derivative of the natural log of e to the x with respect to e to the x multiplied by the derivative of e to the x with respect to x. Now, how can we simplify this equation even further? Well, we're trying to solve for e to the x, remind you. We're trying to prove what the derivative of e to the x is. So let's try to simplify this other expression right over here. And to do that, I want to draw your attention to this one fact. And that is that when we take the derivative of the natural log of x with respect to x, we get 1 over x. And here's the pattern you have to notice. We're taking the natural log of x with respect to x, so we get 1 over x. Similarly, when we take the natural log of e to the x and we take it with respect to e to the x, we're going to get, and now I'm going to switch to my black color, 1 over e to the x. This is going to be multiplied by the derivative of e to the x with respect to x. So let's remind ourselves of what this expression is equal to. It is equal to the derivative of the natural log of e to the x. And we have already solved for that. We know that the answer is 1. So therefore, this expression is equal to 1. And we just need to solve for this term right here, the derivative. How are we going to do that? Well, I'm going to multiply both sides by e to the x. Now that I've done that, on the left-hand side, the e to the x's will cancel out, and we get that the derivative of e to the x with respect to x is equal to e to the x. So hopefully you can see the process by which we took. We first were trying to solve this equation, the derivative of the natural log of e to the x. We did that by first using log rules and finding that the answer was 1, and then using the chain rule to get this expression. Using this expression and knowing that it was equal to 1, we were able to solve for the derivative of e to the x. This has been a Math Proofs video. My name is Adi Oja. Thank you for watching.